Hello everyone, I am Alexa Palacio from DCPET 3P, and today I want to share my thoughts on one of the most revolutionary technologies of our time, the Graphic Processing Unit or a GPU. We're going to explore how GPUs, once tools for gaming, evolve into the backbone of advanced technologies like artificial intelligence, self-driving cars, digital twins, and even the metaverse. As a future engineer, reflecting on this topic isn't just about understanding technology. It is about thinking critically about how these advancements will shape our world and the role we will play in guiding their development. So let's take a deep dive into fascinating evolution of GPUs, their role today, and where they're leading us in the future. GPUs were initially created for gaming back in the 1990s. Video games started demanding more complex graphics, and CPUs, which handles tasks one step at a time, weren't fast enough to meet these demands. This is where GPUs came in. For example, let's look at the modern games. The game stimulates complex environments with realistic lighting, materials, and physics. To make all this possible, GPUs process billions of calculations every second. GPUs are built to process many tasks simultaneously. For gaming, they could handle things like lighting, shadows, and movement all at once, creating realistic environment for players. Think about modern games like any other modern games. The graphics in that game are so detailed that every material, every light reflection, and even the way objects interact with each other needs to be simulated. GPUs make this possible by performing billions of calculations per second. And in 2006, something extraordinary happened. GPU development took a major leap forward. Instead of just a few cores, GPUs started scaling up to hundreds and eventually thousands of cores. This opened the door for GPUs to be used beyond gaming. By 2018, NVIDIA's Volta GPUs had over 5,000 cores, making them capable of handling complex tasks like artificial intelligence and scientific simulations. GPUs become not just faster but also smarter, transforming industries far beyond gaming. When I think about transformation, it's a reminder of how technology can grow beyond its original purpose. GPU were built for gaming, but today they are solving some of humanity's biggest challenges. As a student, inspires me to think creatively about how technologies we create might evolve and impact the world. Artificial intelligence requires enormous computational power. For example, training an AI model involves recognizing patterns in massive data sets, which can take millions or even trillions of calculations. CPUs would take weeks or months to do this, but GPUs can do it in a fraction of the time because they are designed for parallel processing. Instead of handling one task at a time, GPUs can process thousands of tasks all at once. These are the real world applications of AI and GPUs. First is self-driving cars. GPUs play a central role in autonomous vehicles like Tesla Autopilot, for instance, uses neural networks powered by GPUs to analyze data from cameras and sensors. This data is processed in real time to help the car detect objects, avoid obstacles, and navigate roads. Also, in scientific research, GPUs are used in cutting edge research, such as modeling protein folding to help find cures for disease. They also power weather simulation, helping predict natural disasters like hurricanes or typhoons. Even in space exploration, GPUs simulates phenomena like gravitational waves, giving us deeper insights into that universe. And for AI, have you ever used a virtual assistant like Siri or Alexa? These tools rely on AI models trained on GPUs. And seeing how GPUs are helping build safer cars, advance scientific discoveries, and bring AI into our daily lives make me feel hopeful about the future. It's exciting to think that as engineers, we can contribute to these advancements, helping solve problems that seemed impossible just a few years ago. Now, let's talk about the metaverse and digital twins. The metaverse is like a digital universe where you can interact with others as a virtual avatar. Imagine attending a virtual class, hanging out with friends in a 3D environment, or shopping for digital outfits, all from the comfort of your home. GPUs are the engines behind the metaverse. They render the 3D environments and process interactions in real time. So, what are digital twins? Digital twins are virtual replicas of real-world system. For example, a factory with might create a digital twin of its production line to test new ideas without disrupting operations. Cities are using digital twins to manage traffic, optimize energy use, and improve urban planning. And in healthcare, digital twins of patients can help doctors predict how treatments will work. The idea of living in a metaverse or working with digital twin is exciting, but it also makes me think about the responsibilities we have as engineers. We need to ensure these technologies are inclusive and protect people's privacy. Most importantly, we need to strike a balance between the digital and physical worlds. And let's talk about the rapid acceleration of GPU development. GPU performance is improving at an incredible rate. By 2040, GPUs are expected to be 100,000 times more powerful than they are today. Imagine the possibilities. What this could be mean for the future. With GPUs becoming more powerful, AI could be embedded into almost every aspect of our lives, from personal assistants that anticipate our needs to robots that can help with household tasks. The possibilities are endless. And GPUs could power systems that optimize traffic flow in cities or reduce energy waste in homes, making life more efficient and sustainable. As the AI become more powerful, we need to think about how to use it responsibly. For example, how do we ensure AI systems are fair and unbiased? How do we prevent misuse of this technology? And as I think back on everything we've discussed, the evolution of GPUs, their role, their applications in autonomous vehicle, it feels like I've been on a journey once that connects the past, present, and the future of technology. Let's start with how it all began. GPUs were born from a simple need, better gaming. Back then, I'm sure no one imagined that this technology designed to make video games look cool would one day power the artificial intelligence or help scientists unravel the mysteries of the universe. When I think about that, it's a reminder of how small ideas can lead to big changes. As a future engineers, we might work on projects that seem small or specific at first, but those projects could grow into something far greater. The, that's the beauty of innovation. It's unpredictable and it often surprises us. Then there's the role of GPUs in artificial intelligence. This part of me, this part of the journey amazed me the most because AI is everywhere now. Whether it's a virtual assistant, self-driving cars that are becoming smarter every day. But what struck me while reflecting on this is how GPUs made AI possible by providing the computational power needed to handle enormous amounts of data. Imagine this, a self-driving car sees the world with true cameras and sensors, processes that data in real time, and makes me decisions like a human would, all thanks to GPUs. As a student, I find this fascinating because it shows how technology can mimic and even exceed human abilities in certain areas. And then we have the metaverse, a whole new digital world where you can be wherever you want, do whatever you want, do whatever you imagine, and connect with people from anywhere. It's exciting but also a little intimidating. The idea of creating digital twins of virtual replicas of real things feels like science fiction. Yet it's becoming a reality. Cities are building digital twins to manage traffic, and doctors are using them to predict how treatment will work. But here's the part that really made me stop to think. As we move to deeper into metaverse and digital twins, are we losing something? Will we become so immersed in virtual worlds that we forget the beauty of the real world? I believe that the answer lies in balance. Technology should enhance our lives, not replace the things that make us human, like connecting with each other face to face, feeling the warmth of sun, or simply enjoying the world around us. And I want to reflect on the future of GPUs. The speed at which they're improving is mind blowing. By 2040, they might be 100,000 times more powerful than they are today. It's hard to even imagine that will mean. Maybe AI will be so advanced that it feels like talking to a friend. And maybe the metaverse will be also realistic that is indistinguishable from the physical world. But here's the question. Uh, it keeps coming back to me. As an engineer, how do we ensure these technologies are used responsibly? How do we create systems that are fair, inclusive, and beneficial for everyone, not just for companies or those who can afford them? This reflection has made me realize that our role as an engineer is not just about building cool things, it's about building a better future, a future where technology solves problems and connects people and make life more meaningful. I think about my own dream as a computer engineer student. Someday I might work on technologies like this, contributing to AI, uh, or maybe even something we haven't imagined yet. That's both exciting and humbling because it comes with a responsibility. The responsibility to ask, is this helping people? Is it ethical? Is it sustainable? As I wrap up this reflection, I feel both inspired and challenged. Inspired by what we've achieved so far and challenged by the work that still lies ahead. The evolution of GPUs, AI, and show us what possible when we push the boundaries of technology. Now it's up to us, the next generation of engineers, to take those possibilities and turn them into something that truly benefits the world.